Today we are working with section 1.3, writing expressions. Your goal for today is that you will be able to translate a verbal phrase into an expression. We have 3 vocabulary words here already defined for you. Pause anytime you need to take a moment to write the definitions down. A verbal model is an expression that describes a problem using words and labels as labels and using math symbols to relate the words. A rate is a fraction that compares 2 quantities measured in different units, and a unit rate is a rate per one given unit. We will look at examples of all these throughout this section. The first thing we're going to look at is translating verbal phrases. We will look at examples of addition, subtraction, multiplication, and division. When we get to subtraction and division, we will note that order is important when you're writing subtraction and division expressions. We'll start with addition. The verbal phrase, the sum of 3 and a number n, is written as 3 plus n. Or a number x plus 10 is written the exact way that we read it, x plus 10. Now we get to subtraction, where order is important here. One word that signals subtraction is difference. The difference of 7 and a number, a. Is going to be 7 minus a. One way I help to know this is 7 minus a and not a minus 7 is I give a some kind of a value. For example, just give it a value of 1. And I say the difference of 7 and 1 is 6. So 7 minus 1 is also 6, meaning that I got them in the correct order. Or here, 12 less than a number x is x minus 12. I do something very similar here. I give x a value, say something like 13. 12 less than 13 is 1. 13 minus 12 is 1. In multiplication, I'm going to use the words times and product. 5 times a number y is written as this, 5y. Numbers and letters written side by side show multiplication. Or the product of 2 and a number n is written as 2n. For division, we're going to use the words quotient and divide it. So the quotient of a number a and 6 is going to be written as a divided by 6. Just like subtraction, I'm going to give a value to see if I got this right. If I wanted to say the quotient of, let's say, 24 and 6, so 24 divided by 6 is 4. Okay, so the quotient of 24 and 6 is 4. Or 8 divided into a number. When you divide something in 2, that's going to be on the bottom. So the 8 is going to be on the bottom here. Y divided by 8. Let's say that the number is 48. 48 divided by 8 is 6. Okay? 8 divided into 48 is going to be 6. Let's look at example 1. We're going to translate a verbal phrase into an expression here. Our first verbal phrase, and we have a note off to the side that says the quantity. When you see the word the quantity, you're going to be grouping something. Okay? In this case, we're not really grouping anything. It's grouping itself with a variable, but you need to be aware of looking for things like the quantity of, or the quantity when translating something into an expression. So in this case, we have 6 less than the quantity 8 times the number x. Okay, that's going to be 8 times the quantity x is going to be written as 8x. So we write 8x, and it's 6 less than that, so it's 8x minus 6. If you look at some of the examples from the previous slide, that can help you get things in the right order. And then you have these examples also to help you put things in the correct order. For B, 2 times the sum of 5 and a number A. That's another thing that signals, just like the quantity, the sum of indicates that you're going to group something here. This is a little bit different because now you're grouping 5 and A, which is a sum. You're going to be adding. So when we write this, we're going to write this as 2 times, and we're going to use the parentheses to show multiplication here. The sum of 5 and A is written as 5 plus A, and we put that inside the parentheses. And C, the difference of 17 and the cube of a number n. Okay, here we're doing difference of. Like on the previous slide, we had an example of the difference of numbers. When you see the difference of, that 17 is going to go first. So it's going to be 17 minus the cube of a number. That would be n cubed. 17 minus n cubed. Let's move down to the checkpoint. We're going to translate these verbal phrases into an expression. We're going to start with the product of 5 and the quantity 12 plus a number. This is similar to B in example 1, where we're going to have 5 times 12 plus n. Number 2, we don't have an example in example 1 quite like this one, but it's the quotient of 10 and the quantity a number x minus 3. The quotient of 10 means I'm going to do 10 divided by something. Well, I'm dividing it by the quantity of x minus 3, which is going to be simply on the bottom of this division bar, x minus 3. So this whole thing is our answer. Now in example 2, we're going to actually use a verbal model. And we're going to take this in 2 steps here. We're going to write the verbal model and then translate that using just numbers, variables, symbols. It's about a food drive. You and 3 friends are collecting canned food for a food drive. You each collect the same number of cans. Write an expression for the total number of cans collected. We take this first and we make it a verbal model. We say, well, the amount of cans times the number of people is going to give me what I'm looking for. But I'm going to take that because I don't know how many people, I know that there are 4 people, but I don't know how many cans were brought. So the amount of cans is going to be our unknown. We're going to give it a C, something descriptive, times the number of people. There were 4 of you and 3 friends. And so therefore the expression could be C times 4. You could even say 4C. Either way would show that exact expression. And on our last page of notes, we start with the first checkpoint that is similar to the one we just did. It says in example 2, suppose that the total number of cans collected are distributed equally to 2 food banks. Write an expression that represents the number of cans each food bank receives. Well, you and your 3 friends brought C times 4 number of cans. If you want to distribute equally to 2 food banks, that's like dividing everything that you have by 2. And that is your answer. Shifting gears just a little bit, in example 3 we're going to find a unit rate. Unit rate does not have to be difficult. The hardest part of unit rate is putting things in the correct place. we're going to take 3 gallons of milk that costs $9.15. To find the unit rate here, we're looking at the cost per gallon. Well, the cost of the 3 gallons was $9.15, and that was for 3 gallons. Two ways that you can think of when you're working with unit rate. You can say, I've got a 3 here on the bottom, so I'm going to divide the top and the bottom by a 3. So $9.15 divided by 3, and 3 gallons divided by 3. $9.15 divided by 3 would give you $3.05. 3 divided by 3 is 1, meaning that the unit rate is $3.05 per gallon. Or we could write it as 305, a slash for per, and abbreviate gallon. Another probably simpler way of thinking of unit cost is to just think of it as a simple division problem, taking the top, divide it by the bottom, and getting your number, 305, and then putting it per gallon. You want to make sure you have your labels when you're doing unit rate. So let's look at the checkpoint and let's find the unit rates of these. Again, pause, try these on your own, check yourself. For number 4, I would simply think 420 divided by 3 is 140. But again, I want to label this as miles per hour. So I put miles per hour. And I'm just abbreviating. 12 divided by 3 is $4. You're always going to use the label on top first, per foot squared. Because what ends up being in the bottom is actually a 1. You don't really have to show the 1. And then in 6, 20 cups per 8 people. 20 divided by 8 is 2.5 cups per person. This concludes section 1.3. Take a moment to review anything that you may have had trouble with. Come prepared with questions for class tomorrow. Thank you.